so this is a second example. There was one done in class for how to use Hess's law to calculate delta H. So we would like to calculate delta H of reaction for 2 moles of solid carbon plus 1 mole of hydrogen gas to make 1 mole of C2H2 gas. Now, Hess's law provides the following equations. So we need to manipulate these equations to yield an equation that looks like this. So the first thing I'm going to do to make it clear is I'm going to label these equations 1, 2, and 3. You could label them in any way you like, but this allows you to track this information. Okay, so the first thing I like to do is if we know that this is the product and we see that the product is on the reactant side for equation 1, we're going to flip equation number 1. Okay, so I'm going to take the products and now make them reactants to where we have CO2 gas plus 2 water vapors go to make C2H2 gas plus 5 halves O2. Okay, so what happens to delta H? Delta H, when you flip the equation, is the same in magnitude but of opposite sign. So we have delta H equals positive 1299.6 kilojoules. Okay, good. So now we have the product on the product side. Okay, so for the following equation, this has carbon solid, which we need to have 2 moles of here. So we are going to multiply equation 2 by 2. So when we do that, we get 2 moles of carbon solid plus 2 moles of oxygen gas goes to 2 moles of CO2, also gas. Okay, delta H is of the same magnitude. We just multiply that by 2. Which when we do that is negative 787 kilojoules. Okay, so this is good. We now have our product in the correct molar ratio. Sorry, you also have the correct ratio and moles of this. However, if you look at this, one of the things when you get to Hess's law is we're going to sum the equations. So currently we have a little bit too much CO2, as well as we are missing some things here. However, I've noted a mistake. In this equation, it is not balanced. So there are actually 2 moles here. So we're going to add the 2 here, which is good because now these will cancel out, okay? But we still have oxygen and water in places where they can't be. So how can we utilize equation 3 in order to solve this problem? So we know that we need 1 mole of H2 gas. So in this case, we're going to add equation 3. Okay, we're going to add it just as is to where we have hydrogen gas plus half a mole of O2 gas. In this case, this is the heats of formation reactions where half moles are acceptable. This yields 1 mole of liquid water we have delta H equals negative 285.8 kilojoules. Okay, so at this point, we're going to add up the equations. When we do this, we have 2 CO2s plus 2 H2O This is still not balanced. Okay, so here's our list of all of the reactants. This is going to yield all of the products. So we have C2H2 gas plus 2 CO2, still a gas, plus H2O, liquid. Okay, at this point, we are now going to cross out anything that we observe on both the product and reactant side, okay? And use a different color, green in this case, so that we can see where things go. There is water on both sides of the equation. I also forgot the oxygen gas that is here. Okay, doke. Now we're ready. So I forgot this up here. Okay, we still get rid of the water. We have 2 moles of CO2 on either side. We're gonna get rid of that. Okay, so we can sum together this oxygen to where we get 5/2 O2, which is good because on the other side of the equation, we also have 5/2 of oxygen. We're gonna get rid of that. So what do we have left over? We have 2 moles of solid carbon plus hydrogen gas goes to C2H2 gas. This is great. We've manipulated the equations to get back what we were asked for in the beginning of the problem. But what is delta H? So in this case, based on Hess's law, we can now sum together the delta H for each of these reactions. So we have the delta H reaction equals positive 1299.6 kilojoules plus a negative 787 kilojoules plus negative 285 so when we add those together, we get 226.8 kilojoules for delta H reaction. I just want to call attention to some of the mistakes that I made in the typing of this equation. For equation 1, it was improperly balanced. It should be 2 moles of CO2 and only 1 mole of water. Therefore, when I flipped the equation here, I corrected that, which is what allowed us to do this part correctly.